triangle. So this is triangle ABC. I put a right triangle in at C because we're still working with right triangles. That's not going to change until the last part of the unit after next week's quiz. Still dealing with the right triangle. What I want to know is if you are looking at angle A, so from angle A, can you identify what the adjacent side would be, the opposite and hypotenuse? Right? But you have to be looking at angle A and none of the other angles. First one I'm going to ask somebody, I don't care what angle you're looking at. The hypotenuse is the hypotenuse. No matter, we're looking at angle A, B, or C. So what's the hypotenuse in this diagram, regardless of what angle you're looking at? Here we go. Charlie, what's my hypotenuse? AB. All right, I don't care what angle we're looking at. That's going to be AB. Now let's talk about those other two sides. Let me start first with adjacent, which we know means next to. But I know you guys are honors, and you're probably looking at angle A and be like, well, I could give them two answers, right? AC, or I could give them AB. They're both next to angle A. AB is already taken care of. That's always the hypotenuse. So when I ask for an adjacent side going forward, I'm looking for the leg, an adjacent leg. So what is that leg that's adjacent to angle A here? Matt? AC. AC, good. And now I'll also be asking for an opposite side today and all week. The opposite to angle A. What side is opposite across from angle A? Olivia? CB. Good. Now look at angle B and answer the same set of questions, but now looking from angle B. I'll take care of the first one, which is the hypotenuse. That stays. AB. That never changes. Never changes. All right, now what's my adjacent side to angle B? Adjacent side, Amy? BC. Making my opposite side from B. Olivia, back to you. AC. These are the three sides I'm going to be looking for today in the new technique I show you. Last thing, I will never have you go look at the right angle. Why not? What if I say adjacent? Then you have a serious dilemma, which one, right? And then opposite and hypotenuse are still the same. Right, so I am never going to ask you to look from the right angle. It's always going to be from the two, ready? Acute angles. The two angles that are less than 90. All right, that's what I'm going to always look from. All right. I am about to fill you with a whole bunch of vocabulary and new information. All right, so be patient with me. But I promise you at the end, I'm going to come up with this unbelievable way to memorize what I just said without using flashcards or Quizlet. All right, an unbelievable way. So today, I'm going to introduce three new ratios. And if you remember, ratios are a comparison of quantities. Like 2/3 is a ratio. 5/8 is a ratio. One number over the other. The first ratio I'm going to introduce to you, and we got new vocab here. This is called the sine ratio. Sine, S-I-N-E. But when you use it in a problem, you can abbreviate it S-I-N. It's not sin. It's called sine. Everyone good? It's not sin. Yes, that's the way to make my blood boil. I'll call it sin. It's called sine. And the way you find that ratio is you take the opposite side and put it over the hypotenuse in the right triangle. Words I just worked with you on. Right? We take the opposite side and put it over the hypotenuse. That is the sine ratio. The second ratio is called cosine. Cosine. And when we use it in a problem, we abbreviate it COS. Not cos, cosine. We abbreviate it COS. And that can be found by taking your adjacent side and putting it over the hypotenuse. That's how you can find that ratio. The final ratio, the third and final one, is called tangent. The tangent ratio. Abbreviated when we use it in a problem, T-A-N, tangent. And that one is the opposite side over the adjacent side. That's how you find that ratio. So these are the three ratios I'm going to use with you today to find the sideline because the other techniques don't work anymore. These are the three ratios. Now, I told you I have an awesome way for you to remember these without you writing them down on index cards. You're using Quizlet. Anybody familiar with Pocahontas? I just took a left turn right there. I know. Anybody? Yeah, hopefully you know something. Did you know She had a brother. She had a brother. I don't know if he appeared in the cartoon or the movie version, but Pocahontas had a brother. His name will help you memorize the ratios. His name was Sokotoa. That was Pocahontas' brother name, Sokotoa. Luckily for us, if you could spell his name, you'll know the ratios. Here's how. The S in his name stands for sign. Sign. Guess what the O stands for? What have we been talking about that starts with O? Opposite over H for hypotenuse. Look at that. Sine equals opposite over hypotenuse. C for cosine. What do you think the A represents? Adjacent over hypotenuse. And then finally, the T in his name, tangent, is equal to opposite over adjacent. So you can use Pocahontas' brother's name, Sokotoa, to memorize the three ratios I just showed you. Now the big question is, how many of you actually believe that story or think I'm just lying to everybody? You can Google it later, see who Pocahontas' brother was. All right, see if it actually comes up. Sokotoa. Just know how to spell it and you'll be good. Any questions? Because I want to jump right into a problem. I don't want to screw around here today. These are just directions on how to use them. All right, well, you don't need the directions because you guys are going to figure out how to use them by repping out all these problems. So we ready? Let's jump right into the fire. Number one. Don't worry about the steps. I'm not concerned. I'm going to teach you the steps. All right. First thing I want to go over. What is wrong with what we just learned and we used on the quiz? Why can't I use all those techniques right now on example 1 to find x? First, hills and sass. Why can't I use hills and sass here? I don't have an altitude to the hypotenuse. It's not even the diagram I need. Everyone good? All right, so that's out. Pythagorean theorem. What's wrong with Pythag? That's always a go-to. What's wrong with Pythag? I have a squared, 15 squared, but I don't have a b squared, do I? It's blank. I don't even have enough information to use Pythag. Done. Do not overthink this when I ask this. Why can I not use my 45, 45, 90 rules? It's not even a 45, 45, 90, right? Let's be real. And same thing, 30, 60, 90, can't use that because it's not even a 30, 60, 90 rule. So does everyone see why our 4 techniques are useless? We're good there? So this is why I need a new technique, which is one of the 3 ratios. First thing we need to determine, what do I have enough information to use? Sine, cosine, or tangent? Here's how we figure out. We always go from the acute angle that's given. Never go from the right angle. You saw the issues we would have if we went from the right angles. We go from the acute angle, and you tell me what the 15 and the x are. Opposite, adjacent, or hypotenuse. That's what I want from you right now. So looking at 36 degrees, what is the side 15? Opposite, adjacent, or hypotenuse up here? 1, 4. Where are we going here? Gianna, what's the 15? That's the opposite side. I don't care if you do this, but I'm always going to do this up here at the board. I want to remind myself that I have the opposite side, so I put an O in parentheses, just to remind me I have that. I don't care if you guys do that or not. If it's helpful, go ahead. What's the X representing? That's what side in there? That is the 13. Ksenia, what do you have? Hypotenuse, so I'm going to put an H there. I am not going to label the missing. It's not even part of the problem, the blank side. And it's just going to get more confusing if I put an A there. So you have opposite and you have hypotenuse. Which one of the 3 ratios can I now use? That's where I rely on Sokotoa. Remember, as long as you can spell it, you can use it. And I look, oh, what has O and H in it? Which one of the 3 ratios? Do you remember what it's called? Oh, boy. All right, first one here. First one. What was it called, Haley?
Sine.
Sine. Good. Everyone, so I can use the sine ratio. Everyone good. It's going to be sine in this problem. All right, now it's setting up the equation. If I'm going to use sine, you abbreviate it. Here we go. SIN, the sine of your angle that you're using. What angle are we using? 36. So the sine of 36 is equal to the ratio? Either x over 15 or 15 over x, right? Opposite over hypotenuse. So opposite 15 over hypotenuse x. There's the equation you're going to help me solve. Sine of 36 is equal to the ratio of 15 over x. Ooh, now the question is, how do I solve this? What's up, Zeev?
Could you also use angle A and do cosine?
You could find missing angle A and then do adjacent over hypotenuse. You could do that as well, yes. Okay, back to here. How do I solve this? Well, let me help you out. Does this help anybody out if I put this over 1, even though it's not showing? What did I just build right there? From our similarity unit. What is that? It's a proportion. How do we solve proportions? All right, here we go. We're going to cross multiply. So cross multiply this way. Multiply your extremes. I get sine of 36 times x. And if I multiply the means, I get 15. I am taking this really slow. I have to solve for x, though. Get x by itself. So how do I remove sine of 36? How do I move that to the other side? Because I got to get x by itself. Use your algebra skills. How do I move it over? What's happening between the two? Multiplication. How do you undo multiplication? You do use division, right? And I think some of you are just scared off by this sine of 36. All that is a number that your calculator's already programmed to find. All right, it's like 2.856. It's like pi kind of. All right, it's already stored in your calculator. You just got to bring it out of the calculator, and I'll show you how to do that. So we're going to divide both sides by the sine of 36. So our final answer will be whatever 15 divided by sine of 36 is, whatever that number is, and then I'll round it. All right, how do I get to that number? All right, it's a fun day for you. New buttons on the calculator. New buttons. First thing I need everybody to check. Top left-hand corner. Please look at the top left-hand corner of your calculator. Does it say DEG? It should, because all the rest of my classes use the calculator. Anybody not say DEG? Okay. Could you have your own calculator? Okay, now what I need you to do is get it in, just so everybody knows, because I'll do it with Thomas here too. If it doesn't say DEG, which means your calculator's in degree mode. All right, why do I need it to be in degree mode? What are you about to plug in, guys? 36 degrees, so it needs to be in degree mode. So if at any time there's something else other than DEG, like Thomas has right now, here's how you change it. And don't keep it in degree mode. You guys don't need it. But if it's something else other than DEG, we go to the home screen. And Thomas, you want to go all the way down to the bottom right to settings. Okay. Settings, it'll say something other than degrees here. So you enter and then make sure it's in degrees. All right. Just so you know, these are the other ways to measure an angle. All right. That's what these are up here. We will actually be talking radians in a following unit later this year, but we want to be in degrees. So just make sure you're always in degrees, or your calculator's in degrees. So your calculator should be in degrees, and also too, the mode you should be in, calculator in degree mode, you personally, beast mode. Got me? Beast mode when you're doing these. Got me, Will? All right, you find something, you dig deep, and you get that beast out of you. All right, so how do I type in 15 over sine of 36? Some of you guys have probably found it already, but if you have it, 15 divided by, get that out of there. Everyone see it's a 3-pack, right in a row right here. Sine, cosine, tangent. There are 3 new buttons we're going to use. So sine, and then I type in the degree measure, 36. That is a number your calculator already knows that it's going to plug in for you. Close the parenthesis, enter. Don't get scared off by the radicals because we're rounding. All right, look at that too, huh? 30 radical 2 over the square root of 5 minus, wow. Anyway, we don't care. I just want the decimal because we're going to round that. 25.6 for that side length. All good? Did I round it incorrectly? People are looking at me weird. Oh, 25.5. One job. God. You would think this is the 4th time I've done this problem this morning. I think I would have gotten that right. All right, questions on that? One doesn't make you great, but at least we can go a little quicker now, right? All right, number 2. Again, we go from the acute angle. In this case, now we're going from 48 degrees. All right, what sides did I give you? What are the x and what are the 37 here? What are the x and the 37? Shoom. Up 5, back to Haley. What's the x?
Adjacent.
Adjacent. Good work. And how about the 37? Good. All right, what ratio do I now have enough information to use? Sine, cosine, or tangent with adjacent and hypotenuse? Which one of the 3 can I use on this one? Josh.
Cosine.
Cosine. We abbreviate it COS when we write it in the equation. Cosine of your acute angle, 48, equals this ratio now. So the cosine of 48 is going to be equal to what here? Ooh, going deep. Like I should. Z, sorry. X over 37. Feeling the vest there too. Looks good. Got a couple like outdoorsman look to you there, like you're about to go chop down a tree or something. Good. Put that over 1. Anybody's fair game in here. All right. Hope you guys, it's second semester now, thick skin. Everyone's fair game. Hey, if you want to come at me too, go ahead. All right. Just be ready for a harsher comeback. Now watch what happens when I cross multiply here. Something different than what happened up here, right? Because when I cross multiply, I get cosine of 48 times 37, and it's just equal to x. No dividing here. All right. Sometimes you'll divide, sometimes you don't need to. This is a case where I don't need to divide by anything because it's already x equals. So I go to my calculator. Just a warning when you go to your calculator. You type in cosine 48, close that bad boy up. Because if you multiply by 37 inside the parenthesis, your calculator is going to take whatever degree that is and do the cosine of it. All right, I just want the cosine of 48. So close that sucker up, then multiply by 37. And notice I changed the rounding directions on you. Nearest inch. So it's not 24.8. We're going with 25 here. So here's our new technique. To find a side. Because the other 4 didn't work. How's everyone feeling? Anything you want to ask? Because this is it for the quiz. It's just using this in word problems. A couple days we'll do word problems. This is it. Your quiz 2 will be on sine, cosine, tangent. That's it. All right. How about this one? Look at that building. Look at those bricks. A ladder is placed against the house at a 75-degree angle with the ground. What's the length of the ladder? The only reason I want to do this one with you is, do you know what the heck you're solving for? Where's the ladder in here? It's leaning against the house. I can't say that enough and more sarcastically. It's leaning against the house. Do we know what we're solving for in this right triangle now? Not the ground, not the building, the ladder that's leaning against the house. All right, what sides are you given? Let's start there. What's the 15 and the x compared to the 75? Let's have a little fun now. For Doyle, what's the 15? Yes, it is. What's the ladder? Yep, there you go. All right, if you have the opposite side and the hypotenuse, you can use which ratio to solve now? Which ratio? Doyle again, 2 for 2. Yeah, be confident. Sine of the angle, 75 equals, what's the ratio going to be now? What's the ratio? Ooh, Matt?
15 over x.
Good, opposite over hypotenuse. Cross multiply. Ooh, this one you are going to have to divide at the end to find x. Sometimes you will, sometimes you won't. So you are going to have to divide at the end. Oh, it's nearest 10th. I don't think I can get a number there. No decimals on the number generator, sorry. When you have it, let me know. I just want to make sure you can use your calculators correctly. That's why I'm calling on somebody. When you're ready, Ksenia.
I got 15.5.
Darn right you did. Number 2 on your own. Number 2 on your own. Hold up on number 3. Don't go too far. Just do number 2. See where you're going on number 2 on your own. All right, what ratio did you use here? Just let me know. I don't want to know the final answer. What ratio did you use here? Two. Zoe, sorry. Go ahead. I know that. Cosine ratio, yep. Cosine of 40, everybody, equaled 14 over x. Cross multiplied, you did have to divide on this one by cosine of 40. And nearest foot, sorry, we don't have that many kids in the class, but Aiden, what do you got? 18 feet, good. What?
Are we doing the interview?
If we have time at the end, yes. All right, this is a long lesson, so we should have like 5 minutes left, I think, at the end, so we should. Anything else? As long as we don't have like a surprise appearance here, we gotta stop. We're all good? All right, little bit of a different question here. Ooh, 2 clocks, 1 class. Which ratio is always equal to the sine of A? Sine of angle A, which ratio? All right, so no numbers here. I just want to use plain old sidelines, plain old sides. Tell me something you know about the sine ratio before we start this problem. What do you know about the sine ratio? As far as SOHCAHTOA goes, what's the sine equal to? Will, dig deep. Sine ratio. What's the O and the H?
Opposite over.
You should be sorry. Good. Opposite over hypotenuse. I think I only mentioned this once, but sine, cosine, tangent, only in right triangles. All right, we're still in right. All this stuff can only be used in right triangles. No need to get nervous. All right, only can be used in right triangles. And hey, take a look. The only right triangle I see up here is ADE. Right, triangle ADE. That's a right triangle. So can somebody give me the opposite and hypotenuse in triangle ADE from angle A? From angle A and triangle ADE, what's the opposite and hypotenuse? So I can write it down and answer the question. 1, 3. I'm worst at memory. Ksenia, what's the opposite side from angle A?
D.
Yeah, it's DE, and what's the hypotenuse in that triangle?
80.
She's correct. 100%. It's not a choice, though. I gotta be missing something here. It's not a choice, but it is correct. But unfortunately, it's not a multiple choice. I must be missing something. I should have talked about this at the beginning. Everyone see what they gave us? That's kind of odd that they gave us BC was parallel to DE. That's kind of odd, and probably for a reason, though. This didn't work here. Z, what's the problem? Aren't these 2 angles congruent because they're what type? Big word, big word. Corresponding, yes. So if angle E is a right angle, oh, wait a second. There was another right triangle in the diagram that I could have used instead of the big one. So let's use that one now. Let's use triangle ABC and do the same thing. Let's do the same thing here. Give me the opposite side and the hypotenuse now. Zoe, opposite side from A. BC, hypotenuse. And look at that now. I believe that is a choice. All right, so we had to recognize that there were not one but two right triangles I could do this on. Any questions before we get to our dynamic duo of the second semester? Big Al and little brother, little Mike. They're always competing with each other. Big Al wrote an equation, so did little Mike. Who's correct? Are they both? None? One into the other? Let's figure it out. So let's look at Big Al's equation. Let's see. You let me know if Big Al's correct. He said the sine of 28 is equal to something. Well, let's do this ourselves now. What is the sine of 28 equal to? What ratio is it equal to? So tell me something about sine. Olivia, what's sine equal to? SOHCAHTOA, what's, okay, ready? What's opposite 28? Okay, so I'll plug that in. And then over the, which is how long? All right. We just did that. Big Al's correct, isn't he? Everyone agrees? Big Al, he's correct? Yeah. All right, let's go to the little brother now. Mike. Cosine. Whoa. 62? Should I just say he's incorrect now? 62. Where's that come? Are you kidding me? 62? One job, little Mike. Where's he getting the 62 from? Where's that 62 coming from? What's your deal?
The other angle.
Hey, all these add to 180. If you do 180 minus 90 minus 28, he's like, you know what? I'm not going traditional. I'm going on my own. 62. He's using angle H now to do this. All right, so let's use angle H. Cosine. What do you know about the cosine ratio? Oh, 6. Going back. Thomas, what's cosine equal to? Okay, stop. What's adjacent to angle H? Over. Go ahead, continue. Which is? Look at that. All right, he was correct. We had to identify that he was using the other angle, right? The other angle. So they are both correct. Now you're going to see me get fired up. Not that I haven't been all day. Drawing your own diagram. It's going to happen now. All right, where you're going to have to draw your own diagram. This should be good. Well, we know our diagram should look like a what?
Triangle.
Not just a triangle.
Right triangle.
A right triangle. Yeah, that's what the unit we're in here, right? So our diagram's got to look like a right triangle. Oh boy, here we go. Here's where the fun begins. A 4-foot ladder leans against the building. Do we know where we're putting 4 feet now? Leaning against the building. Where are we putting the 4 feet? On the hypotenuse, right? It's the only thing that's leaning in the darn diagram. I'm not done yet. And that ladder forms a 71-degree angle with the ground. The ground. Everyone knows where the ground is, right? Your feet are now presently on the ground. So out of these two remaining angles, where am I going to put 71? On the top or the bottom? The ground. Thank you, Gabby. I hope so, right? Our feet are on the ground. Wait till we do shadow problems next week. Oh, boy. Kids try to figure out where their shadow is. How high up on the wall is it going to reach? You good?
Yeah.
Something wrong with you?
No.
You good, Matt, or what?
I'm good. I don't know what
Oh, boy.
It's Spanish.
Oh, yeah, everyone's rattled. Which leg am I solving for then? How high up the wall it reaches. The wall, not the ground, the wall. Vertical or horizontal leg. Everyone laughs, but people get it wrong. And wait till we do the shadow problems next week. Nobody understands the shadows on the ground. They think it beams off your forehead when you walk outside. All right, we ready? You're a freak of nature if that happens. All right, what's the x and what's the 4 now? What's the x and what's the 4? Whew, let's go, Will. What's the x? That's my what side? Opposite. And how about the 4? Good. Which of the 3 ratios can I use in this equation if I had the opposite and hypotenuse? 15, Gabby?
Over H.
Yep,
Oh,
we're
X-
getting there.
X-
No. Easy. Don't show off. I just want to know which one of the 3 ratios do I use here?
Oh, sorry.
Sine. Thank you. That's all. You're good. So the sine of 71 equals, what's my ratio here? 12, Olivia, equals x over 4. Opposite over hypotenuse. Good. Hey, we don't even have to divide here. I'll even do it on the calculator with you. Oh, even got the great Amy here as well, huh? Oh, yeah, let's go. Oh, 3.8. We're good. 3.8. That rounds at 3.8, right? Everyone's incorrect. You're all wrong. You're all wrong. It's not 3.8. And I'm going to do this to you more and more in this unit. We got to be locked in to the diagram and what I ask you to round to. What do I mean by that? How long was the ladder, kids? 4 feet. Read those rounding directions again. Round your answer to the nearest tenth of an inch. Oh, so hey, like my 3.8, but that's in feet because your ladder was in feet. I'm going to do that more and more where, hey, the diagram will be in a unit, but your answer needs to be in a different one. So you need to convert. I'm telling you, it's going to happen more and more. You've got to be locked in on the problem. Just don't read through and find the numbers anymore. I got to see, does my diagram match what they're asking for in the answer? So my answer of 3.78, get everything written here, 2074, 302, that is feet. Not what I want. I want inches. So how do I convert that? How do I convert those feet to inches? Multiply it by 12. Now your answer's in inches. 45.4. Be awake. Does my diagram match what I'm asked for in the answer? Now look, maybe you recognize that you're going to get better at this. You will. I just fooled everyone because nobody knew what was going on. All right, but you're going to get better at this. If you see it right away, you can convert your diagram, so you don't have to worry about doing it at the end. All right, so I can convert this 4 times 12, 48 inches, and then not have to worry about it at the end. But be on the lookout now. Be on the lookout. All right, you got 6 on your own. Hey, let's be on the lookout right now, right? The side is in centimeters. What am I asking you to round to? Okay, so we don't have to worry about it. All right, that's what I mean. Figure out what your sides are in the diagram, and then what am I asking you to round to?